I give up. I can't figure out what to do for my IA project. This is literally impossible.
Abby, zip it, will you? I'm trying to watch TV in here. If you need your mum, she's at the gym and she'll be home soon. Take a break and get a snack or something.
Wait. No. That's actually a really good idea. TV, exercise, and food. Maybe those could tie in with what my project should be about.
Finally. Now, go and do some work.
Watch out, IB Math Studies. I'm about to work some who, what, when, where, why magic on y'all. So, we know that obesity is a problem here in the US, but do we really know how big of a problem it actually is? As an average American, we probably don't think about those things, but the epidemic of obesity is growing right under our noses. We often associate obesity with adults leading a sedentary lifestyle, but in fact, kids are actually being affected by this more than we'd ever expect. Now, my dad's comment inspired me to look more into what lifestyle factors could affect the youth and adult obesity rates in the US. First, exercise. Second, TV watching. Cooking! And now, we need our data sources. I'm looking for data sources that are publicly accessible, that are government databases, that have wide varieties of different types of data, that may have graphs or just a bunch of numbers, but I want something that's easy to be able to plot into multiple different charts. And now, methodologies. I used 4 main different methodologies. First, box and whisker charts, then linear regression, then the Pearson correlation coefficient, and then the dreaded chi-squared test. The reason I used a chi-squared test is because I wanted to find a categorical variable, and it was sadly the easiest way to be able to do that. Chi-square tests then accept or reject a hypothesis that you put in place. So my new hypothesis was that the lifestyle factors, television watching, diet, and exercise level, had no correlation whatsoever with obesity rates in the US, be it youth or adult. What's the purpose of the project? The main purpose of this project is to determine if there's a correlation between youth obesity rates and adult obesity rates in the 5 regions of the United States. After much searching to find a usable data set, I settled on the CDC and the US Census. By using the US Census, I managed to find out how many people approximately lived in each of the 5 US regions. The CDC has data on adult and youth obesity rates, so I thought that would come in handy as well. I compiled all of this data into an Excel spreadsheet, and then I was ready to go. And now, let's head on over to the kitchen to learn why I used box and whisker plots. So, first up, box and whisker plots. I plotted the youth and adult obesity rates for all 50 states into a box and whisker plot. And bam! The box and whisker plot shows that there was a wide variation in my data. Clearly, the median suggests that the obesity rate has been increasing over time. With so many data points, there was a lot of noise in the data, so I really wanted to limit it down so there wasn't as much confusion. So I decided to only look on a regional level instead of a state level. Next, I wanted to explore the relationship between obesity rate and time in years to try and understand the trend in the data. So I used the formula where y equals obesity rate, x equals the year, and n equals the increase in obesity rate each year. So, I modeled the youth and adult obesity rate, and modeled the rates for the 5 US geographic regions, which, if you don't know what they are, there you go. Using Excel, I was able to divide and graph all my data into 5 nice little graphs. The total graph is all of the percentages together, so it's a little more confusing, so I chose to just stick with the small 5. So, with this data graph, I figured out that the youth and adult obesity rate are increasing over time. And I really want to know, are they correlated? They're both growing, so obviously they have to be correlated, right? Well, maybe not. I'm going to stop eating my cucumber, move on to the ice cream, and move on to my lifestyle factors as well, so we can see if my hypothesis is correct. So, what can we do about the worsening obesity rates? Well, I explored the correlation between youth obesity rate and adult obesity rate for 2011, 2013, and 2015 data by state and region. And the results were similar, so I'm only going to go off of my 2015 data. I looked at this data from two different lenses, one from regional and one from state. I calculated the correlation using the Pearson correlation coefficient. This shows a moderate correlation between youth and adult obesity rate, with R equaling 6.96. So, close to 1, but not exactly 1. The Pearson correlation coefficient is calculated with this lovely formula, where n is the number of data points, Sx is the standard deviation of x, and Sy is the standard deviation of y. Okay, you can get out of my face now. Okay. The relationship's positive and shows a strong relationship between youth and adult obesity at the state level. Because the R value is 0.696 and it's close to 1, and provides increasing evidence that youth obesity and adult obesity are related. Now I get into my lifestyle factors. First, not enough exercise. Second, too much television. And third, variability in diet. If we understand what causes obesity in youth, we might be able to help adults in the future. For a measure of not enough exercise, I looked at the percentages of high school students who get less than 60 minutes of activity per day. And for TV, I got the percentage of students in grades 9 through 12 watching more than 3 hours of TV a day. And for diet, I did the percent who consume vegetables less than once a day. First, find the correlation of each for actual TV times and obesity rates. And second, the chi-squared goodness of fit test. Using the Pearson correlation coefficient, I found that there was a moderate correlation between the percentage of kids who watch more than 3 hours of TV a day and the obesity rate, and my R was 0.66. Using the same analysis as above, I found that there was no correlation between activity levels and obesity levels. I'll get back to that in a minute. Using the same analysis as above again, I found that there was a moderate correlation between diet and obesity levels, and that R was 0.69. The data I collected showed a significant variability by state, and I wanted to simplify the analysis to see if we could crack this obesity epidemic down further. So I chose to find a categorical variable with the chi-square test. Chi, 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 chi-squared test. Fine, I'll just drink your tea. Sorry. BMI is calculated using the formula BMI equals kilograms divided by meters squared, where kilograms is someone's weight in kilograms and meters squared is their height in meters squared. A BMI of 25 or more is overweight and 30 or more is obese. But if you go down to 18.5 to 25, that's when you're in the normal category. BMI doesn't take ethnicity, bone size, muscle mass, or sedentary lifestyles or anything into account, so sometimes it can come up with pretty funky labels for people. Now, some athletes are going to pop up next to me, and I want you guys to try and figure out what you would classify them as, and then we're going to stick a big fat BMI label on there and see if I can prove you wrong. So, what do you think? Obese. This one? Underweight. What about this one? Come on, you better figure this out. We're gonna slap a normal on that one. So, BMI isn't always accurate. I mean, sometimes it can be, but if you take a linebacker who's 300 pounds and then someone who's just a couch potato and weighs 300 pounds, they might have the exact same BMI, even though one of them is a professional athlete and the other one watches too much Game of Thrones. So, it is possible that as activity rate increases, the obesity rate could also increase because BMI is increasing. And that can confound my analysis. In the end, I found that the trend in youth and adult obesity is increasing. Both rates are highly correlated to each other, so when one goes up, the other does as well. Targeting childhood obesity could be the key to lowering adult obesity rates. I found that 2 of the 3 common factors are highly correlated to obesity rates. The 2 that are clearly related are hours watching TV and diet. The one that isn't is exercise, which was really surprising to me, and honestly, I'm not very happy with that result. The commonly accepted way to lose weight is to exercise more, but that doesn't statistically work. The limitations of BMI is a pretty good measure of this. Now, over to Dinner Abbey with some extra news. Recently, the Trump administration released legislation that said that dietary requirements didn't need to be met in school lunches. Because of this, schools aren't required to offer healthy options to their students. My analysis suggests that this could increase youth obesity rates. Thanks Dinner Abby. The data and analysis in this just begins to crack the surface of what the obesity rate in the US really is. With more data available in the future, we may be able to get a better picture of what the obesity rate in the US really looks like. Until then, we should focus on implementing solutions that target childhood obesity to therefore lower the adult obesity rate.
So I expected this to work. Did it? No. Well, it kinda did. I'm peeved. This is not the result I wanted. I thought that if I ate healthy, didn't watch much TV, and exercised, that I was gonna be healthy. But no. Statistics prove otherwise. So thanks. You know what? I'm just gonna keep eating my ice cream alone in a corner. This is technically a sit-up position, right? Who, what, when, where, why? Who, Abby, what, eating ice cream, when, currently, where, in a corner in my house over by a Christmas tree. Why? Because statistics didn't play in my favor. It works. Cookies!